so let's begin. Those persons that are streaming live, please, you can inform them there's no way to take my WhatsApp phone. You can tell them to connect. Because when they come on the YouTube channel, they will see the live and they can join the live so that they can participate in the class. After these are last class for the semester, during the holiday, when you've gone back for break, we'll be having live sessions, alright, where you can stream from the comfort of your homes. I'll introduce you guys to those studying medical courses and introduce you guys to anatomy, physiology, and medical biochemistry. That's for college departments. Then for faculty of science, we'll have an introduction to foundational biochemistry and advanced organic chemistry. Alright. You don't know that there is advanced organic chemistry? Anybody with a spare handkerchief? Anybody with spare any handkerchief you're not using? Burros. Alright, so today we'll be looking at almost everything in organic chemistry. We'll start, please, no noise. We'll look at almost everything in organic chemistry. We are going to start with, we're looking at, I've summarized all the reactions to just 20 important reactions. Listen up. I believe you've seen the past questions. The exam question is based on reaction and nomenclature. And the nomenclature I'm going to say is mostly from geometric isomerism. Alright? So we'll look at that today. We're going to start from the easiest till we get to the complex aspect. So let's begin. For those coming for the first time, we have a simple rule. Once it is time to learn, you do not talk. If you talk and distract me or you distract your seatmates, you will go home. I will help you go home. stream online instead of waiting for me to upload the video. Alright, let's begin. We have just 3 hours. I won't exceed 3:30. We have 3 hours, there's no break. So, are you ready? I don't know if those streaming live can hear me. Please, somebody here should just join the live and see if you can hear me. Yeah? Just try. Somebody should just join the live and see if you can hear me. You can? You can, Abi. Alright, so let's begin. Alright, let's start. Okay. We're starting from metal. Please give me your audience. Please give me your audience. I don't want you to make a noise so that everybody can hear what I'm saying. We're starting from metal. Elements in the periodic table are grouped into metals and non-metals. Elements in the periodic table are grouped into metals and non-metals. There are there are 7 basic properties. There are 7 basic properties. There are 7 basic properties of metal. There are 7 basic properties of metals. Number 1, all metals in the periodic table have a high boiling and melting point. The first characteristics of metals is high boiling and melting point. That's the first characteristics of metals. Number 1, they have high boiling and melting point. High boiling and melting point. Number 2, they have a high density. They have a high density. Number 2, they have a high density. Basic properties of metals. Number 1, they have a high boiling and melting point. Number 2, they have a high density. Number 3, they exhibit characteristic luster appearance. It means they are shiny in appearance. Number 3, they exhibit characteristic luster. Luster, L-U-S-T-E-R. It means they are shiny. All metals, they have a shiny appearance. Number 4 characteristics of metal is that they are good conductors of heat and electricity. They are good conductors of heat and electricity. They are good conductors of heat and electricity. That's number 4. They are good conductors of heat and electricity. Why are they good conductors of heat and electricity? Is because they have what is called mobile electrons. They are good conductors of heat and electricity, and the reason is because they have mobile what? Electrons. Number 5 characteristic of metal, they are malleable. They are malleable. Malleability. M-A-L-L-E-A-B-I-L-T-Y. Malleability. Malleability of metals is metals being hammered into sheets, just like the zincs you have. You have aluminum sheets, iron sheets. They are malleable. It means they can be hammered into sheets. They are malleable means they can be hammered into sheets. Number 6 characteristics of metal. Number 6 characteristics of metal is the fact that they are ductile. They are ductile means they can be drawn. They can be drawn into wires. They can be drawn into wires. They can be drawn into wires. Number 7 characteristics of metal is that they are not brittle. It means they do not break easily. They are not brittle. It means they do not break easily. So all metals in the periodic table, they exhibit these 7 characteristics. Number 1, we said they have a high melting and boiling point, isn't it? Number 2, they have a high density. Number 3, they exhibit characteristic luster. It means they are shining in a what? Appearance. Number 4, they are good conductors of heat and what? Electricity. Number 5, they are malleable. It means they can be hammered into what? Sheets. Number 6, they are ductile. It means they can be drawn into what? Number 7, they are not what? Brittle. Please take notes. One metal, only one metal in the periodic table, one metal in the periodic table does not exhibit these 7 characteristics, but it is regarded as a metal. This aspect of metals, you will just expect 2 questions in your exam. One metal does not exhibit these 7 characteristics, but it is called a metal. And the name of that metal is called mercury. Mercury does not exhibit these properties, but it is called a metal. Please take note. Mercury is the only metal that is liquid in its form at room temperature. The only metal that is in liquid state. The only metal that is in liquid state at room temperature is mercury. There is another metal in the periodic table. We said metals. Hope you got this information about mercury. Mercury is the only metal that does not exhibit these 7 characteristics, but it is regarded as a what? Metal. Sodium and potassium have a low melting point. Sodium and potassium have a low melting point, but a high boiling point. They are also regarded as metal. Sodium and potassium have a low melting point, but a high boiling point. They are also regarded as metal. Let's look at some metals and their reduction process. The metals that is of cognizance to us, the metal that we are interested in, is known as iron. the metal we are much interested in is called iron. Please take note. Please take note. Take note. This is where I want you to take note. They can ask you which of the following is not the characteristics of metal. Which of the following is not the characteristic of metal? You know the 7 characteristics of metal. Please listen up. Listen up. Don't get confused or distracted. I said we want to look at the metal iron. Iron is obtained naturally in its free form as meteorites. Meteorites, the free form of iron. There are other major ores of iron. The major ores of iron are the hematites. Please, what I want you to take note of in this aspect is the formula. Hematite is Fe2O3. Another ore of iron is called magnetite. Magnetite is Fe3O4. Another ore of iron is called iron pyrite. Iron pyrite is iron 2 sulfide. And the last ore of iron is called limonite. And it is Fe2O3.H2O. Iron occurs abundantly in hematites. Please take note. Iron occurs at 98% naturally in hematites. The reduction process of iron is by chemical means. Did you get this information? Yes. The reduction process of iron is by chemical what? Means. What do we mean by chemical means? It means for us to get iron from hematite, this hematite has to go through a reduction process using a chemical known as coke or carbon monoxide. Using a chemical known as coke or carbon monoxide. Iron is extracted from hematites by chemical means using coke or carbon monoxide. There are 3 types of iron. There are 3 forms of iron. 3 forms of iron. There are 3 forms of iron. Number 1, there are 3 forms of iron. Number 1 is the pig iron. Number 1 is the cast iron. And number 3 is the rough iron. What you need to take note of, listen up please. Pig iron contains carbon impurity about 5%. It is called pig because it contains impurities, carbon impurities about 5%. Your exam is subjective. Subjective. So the question they're asking you are questions in between lines. Pig iron contains carbon impurity about what? 5%. Cast iron is obtained from pig iron. Is obtained from pig iron. Cast iron is obtained from pig iron and it contains slight impurities of carbon. It contains slight impurities of carbon. While wrought iron is the purest form of iron. wrought iron is the purest form of iron. Wrought iron is the purest form of iron. It contains only 0.5% impurity of carbon. It contains only 0.5% impurity of carbon, wrought iron. You can be asked, the purest form of iron is dash. The answer is what? Wrought iron. The most impure form of iron is dash. What's the answer? I said iron is obtained by a reduction process using what chemical? Coal or carbon monoxide. At this point, we've extracted important information from metal. Let's look at isomerism. Under isomerism, we'll be looking at the can-ingot preload sequence. Is there any question from this? Ask. Where is? From the cause of, you can see, all these are forms of ions, alright? You can obtain iron from hematite, you can obtain it from magnetite, you can obtain it from this or that. But iron exists mostly. Iron is the second most abundant metal on the earth crust, hope you know. The first one is which one? The most abundant metal in the earth crust is which one? Are you serious? Who is saying magnesium? Aluminium. Followed by iron. The most abundant, listen, the most abundant non-metal on the earth crust is which one? Yes, somebody was saying there, look what? Thank you. God bless you. Silicon. You're working on it. Sand, silicon dioxide. Alright. Somebody is surprised. Don't be surprised. Let's look at isomerism. Isomerism. Isomerism is defined as a process whereby an organic compound contains or has isomerism. Look at this word, isomerism. The last two letters or alphabet in this word is what? S and M. Are we good? Isomerism is a process, listen up, isomerism is a process whereby an organic compound have the same molecular formula. They have the same molecular formula, S and M. The same molecular formula but different structural formula. Isomerism is a process whereby an organic compound or a hydrocarbon possess the same molecular formula but different structural formula due to their arrangement in space. Due to their arrangement in space. That is what we refer to as what? Isomerism. Isomerism is broadly classified into two major types. I will tell you the aspects you need to take note of because of your exam. Under this isomerism, we also look at nomenclatures too, so please give me your audience. I said isomerism is broadly classified into two types. Number one type is called the structural isomerism. Number one is called the structural isomerism. And number two type of isomerism is called stereo isomerism. Stereo isomerism. There are two broad classification of isomerism. Number one, structural isomerism, and number two is what? Stereo isomerism. isomerism, they have the same molecular formula but different arrangements of the atoms. Please take note. Structural isomerism, they have the same molecular formula but different arrangements of the atoms. They have the same molecular formula but different arrangement of the atoms. That's structural isomerism. Stereoisomerism have the same structure but different arrangement of atoms. Please take note. Stereoisomerism have the same structure but different arrangement of atoms. Please follow me so you don't get confused. There are 5 types of structural isomerism. Number 1 is called chain isomerism. There are 5 types of structural isomerism. Number 1 is called what? Chain isomerism. Number 2 is called positional isomerism. Positional isomerism. Number 3 is called functional group isomerism. Functional group isomerism. Number 5 type of structural isomerism. Number 4 rather. Number 4 is called metamerism. And number 5 is called Isomerism. These are the 5 types. Please listen up. These are the 5 types of structural what? Isomerism. The types of the second aspect, stereoisomerism, there are 2 types. Number 1 is called geometric isomerism. They call them geometric stereoisomers. And number 2 is called optical stereoisomers. Under optical stereoisomers, please listen up. Under optical stereoisomers, there are 2 types. We have dextro-rotatory and we have libo-rotatory. Under geometric stereoisomers, we have cis and trans. Cis, same face. Trans, opposite face. Another name for trans is called E. Another name for cis is called what? Z. So let's talk about this isomer. Your exam is focused on chain isomerism and geometric isomerism. Your exam is focused on chain and geometry. But we'll talk about each of them briefly because I'm going to use them to teach you nomenclature. Is there any question at this point? No. We move. Please, those online, can you hear us? You respond. How to tell? This is my first time streaming a live video.
isomerism involves a reduction in the carbon-to-carbon chain. A reduction in the carbon-to-carbon chain. For chain isomerism, you need to know how to write the isomers of a particular hydrocarbon. For example, give the possible isomers of, let's take butane. Butane is C4H10. Give the possible isomers of butane, C4H10. Please listen up, please. C4H10 means I have one carbon atom. CH3, CH2, CH2, and CH3. This is butane. Sometimes it is referred to as N-butane. N-butane means normal butane. If I'm asked to give the isomers of butane, this is chain isomerism. What do? I know that the longest carbon-to-carbon chain is 4. The next thing to get the first isomer, you reduce it from 4 to 3. If it was 5, you reduce it from 5 to what? 4. So, since it is 4 carbon, we reduce it from 4 to what? 3. So I have CH3, CH. Let's do it this way so nobody gets lost. Look at it. Just write from 4 carbons, we reduce it to 3. 1, 2, and what? 3. Please listen up. From 4, I reduce it to 3. Remove 1 CH3. Remove 1 CH3. Since I've reduced it from 4 to 3, remove the CH3, the first CH3. When you remove the first CH3, you do not attach it to the first carbon. You must attach it to the second carbon. This CH3, the first thing I did was 4, N-butane. I reduced it from 4 to what? 3. When I reduce it to 3, I attach the CH3 to carbon what? 2. Attaching it to carbon 2, here is CH3, here is CH3, and here is H. Now, it corresponds to 4 carbon atoms, 1, 2, 3, 4, and 10 hydrogen. If you name this, this is 1, 2, and what? 3. This is 2-methyl what? Propane. 2-methyl propane. 2-methyl propane is an isomer of N what? Butane. If you remove this CH3, see what we are doing in chain isomerism, we reduce the chain, this CH3 we add it to carbon 2, we remove it from carbon 2, place it at carbon 3, if possible, if there is a carbon 3. If I remove this CH3 and place it at this carbon, it is still the same what? Butane. Look at, if I remove this CH3 from here and I place it here, it is still the same what? Butane. You don't add the CH3 to the first or the last carbon. You add it to the second or the third if you have a third carbon. The CH3 you remove, you add it to the second or the third, not the first or the what? Last. So the two isomers of N-butane are butane and what? 2-methyl propane. Please take note. N-butane is an isomer of itself. N-butane is an isomer of itself. So how many isomers does butane have? 2. There are how many isomers in N-butane? 2. Let's look at N-pentane. Let's look at N-pentane. Pentane is C5, H what? 12. Now let's start. C5. Let's start with the structure of N-pentane. CH3, CH2, 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 and CH3. 1, 2, 3, 4, and what? 5. Now this is N-pentane. My first isomer is N what? Pentane. To get the next isomer, since it is 5 carbon atoms, you reduce it to how many? 4. So I reduce it to 4. 1, 2, 3, and what? 4. This CH3 I remove, I'll add it to, is it carbon 1 or carbon 2? Carbon 2. Carbon 2. If I add the CH3 to carbon 2, this is CH3. Here I have CH3. Here is CH2. Here is CH3. And this is hydrogen. The name of this structure is 2-methyl what? Butane. So 2-methyl butane is another isomer. 2-methyl butane is another isomer of N-pentane. Since I've reduced it to 4, if I remove this CH3, you keep removing changing the position of CH3 to change the name. If I remove this CH3 from here and I take it to this carbon here, is it the same 2-methyl butane? Yes. Look at, if you come from here, 1, 2, 3, and what? 4. If I remove that CH3 from here to this point, it is still 2-methyl what? Butane. So I'm done with 4. I will now reduce it to how many? 3. When I reduce it to 4, I have 2-methyl butane. Now I'm going to reduce it to 3. If I reduce it to 3, I'll have 2 CH3. If I reduce it to 1, 2, 3, I'll have CH3 and what? CH3. So let's reduce it to 3 and see the isomer we're going to get. If I reduce it to 3, I'll have 1, 2, and what? 3. Now, that CH3, remember, I reduced it to 3. 1, 2, and 3. I have 2 CH3, 1 CH3, and the other CH3. And we said we do not add the CH3 to the first or the last carbon, isn't it? Yes. We always add it to the what? The second. So if I have CH3 here, since I have 2 CH3, I'll write the other one what? Above. So at this point, look at this. This corresponds to 1, 2, 3, 4, 5. 5 carbons, C5. Alright? If you count the hydrogen, it's going to give you what? 12. If I want to name this, if you count 1, 2, 3, 1, 2, 3, the longest thing is what? 3. 1, 2, 3, 1, 2, 3, 1, 2. Anyhow you want to count it in any direction, it is still how many? 3. And 3 is what? Pro. Isn't it? Yes. So if I count this way, 1, 2, and what? 3. At carbon 2, I have 2 methyl groups up and down, isn't it? Yes. So this is going to be what? 2,2-dimethyl propane. 2,2-dimethyl propane. This is the last isomer of pentane. So how many isomers does pentane have? 4. How many? 3 or 4? 3. N-pentane is an isomer of itself, 2-methyl butane, and what? 2,2-dimethyl propane. Now I want to ask you a question, very important. This isomer of N-pentane, 2-methyl butane, how many primary carbons are present here? 3. How many primary carbons? 3. If you do not understand the concept of primary, secondary, tertiary carbons, there are a whole lot of videos on the YouTube. You can check them out. How many primary carbons? 3. This is the primary carbon, this is the primary carbon, and this is the primary carbon, isn't it? Yes. How many secondary? 1. How many tertiary? 1. Is there a quaternary? No. Thank you. So they can ask you, give an isomer of N-pentane, that contains 3 primary carbon, 1 secondary carbon, 1 tertiary carbon. They can ask you a question like that. Give an isomer of pentane that contains. All right, so let's proceed. We said we're working on this, the isomers of N-methane. how many isomers do you have? How many? Have you gotten up to 2? Alright. The first isomer you have is what? 2-methyl. The first isomer is N-hexane. Don't forget. The second isomer is what? 2-methyl-pentane. 2-methyl-pentane. The third isomer?
3-dimethylbutane.
3-methyl what? Pentane. There is 3-methyl, there is 2-methyl, isn't it? Yes. Remember, this is 6 now, isn't it? If you reduce it to 5, you have one CH, isn't it? Look at, this is 6. If you reduce it to 5, 1, 2, 3, 4, and what? 5. This is carbon 1, carbon 2, carbon 3, 4, and carbon 5. That CH3, you put it here. If you keep the CH3 here, this is 2-methyl what? Pentane. If you remove it from carbon 2, and you place it at carbon 3, this is 3-methyl what? Pentane. After you reduce it to 5, you reduce it to how many again? 4. Are you following?
Yes.
If you reduce it to 4, what do you have? 2,2-dimethyl what? Thank you. We have 2,3, isn't it? Yes. We still have 2,3. 2,3 dimethyl what? Is there another one? No. There is no manipulation to get another one again. These are the isomers of hexane. So hexane, how many isomers? 5. Hexane, we have 5 isomers. N-hexane, 2-methyl-pentane, 3-methyl-pentane, 2,2-dimethyl-butane, and 2,3-dimethyl what? Butane. Alright, let's look at positional isomerism. Let me just use this to explain positional isomerism. Positional isomerism, look at this. If I have something like this, CH3, CH2, one, two, three. Look at this. 1, 2, 3, 4, 5. Look at this. Listen up, listen up. Look at this structure. What's the name of this organic compound? Is it 2 or 3 pentanol?
3 pentanol.
If you number from this direction, 1, 2, 3, 4, 5. The OH is at carbon where?
3.
So this is 3 what?
Pentanol.
Isn't it?
Yes.
In positional isomerism, we want to reduce the chain. This one, we keep reducing the chain. It's called chain isomerism. In positional isomerism, we do not tamper with the chain. We just change the position of the subsequent. This OH is at carbon 3. If I remove it and place it at carbon 2, like this, the name changes from 3 pentanol to what? 2 pentanol. The more you keep changing the position of the subsequent, we refer to that as positional what? Isomerism. In positional isomerism, there is no reduction in the carbon to carbon chain. In positional isomerism, we do not reduce the carbon to carbon chain. Another important isomerism you need to take note of for your skin is called metamerism. Metamerism occurs in ethers. Metamerism occurs in ethers. Please, if you have any question, ask. Feel free to ask. Metamerism occurs in ethers. Metamerism occurs in ethers. It's either you call them ethers or epoxy compound. Their general formula is an alkyl group bonded to oxygen and an alkyl group. An example of an ether is CH3, CH2, CH2, O, CH2, CH3. Please listen up. Listen up, please. Listen up. Ethers have a reduction and nomenclature. If I want to name an ether, if you want to name an ether, I can name it from forward or backward. Alright? But I was instructed, please listen. Your skin, listen. If you want to name an ether, you start with the shortest oxy group. What do I mean? If you count from the left-hand side before you get to this oxygen, 1, 2, 3, you have how many carbon atoms? 3. After the oxygen, you have how many carbon atoms? 2. 3 and 2, which one is shorter? 2. So it means you start with this one that is shorter. Listen, oh. If I have another example, CH3, CH2, CH3. Please listen up. This one, I have one carbon. One carbon is what? Met. I have one carbon before I see what? Oxygen. After the oxygen, how many carbon atoms? 2. It means you are starting with the smallest oxy substituent, which is what? CH3, 1. If I want to name this, I will start from the smallest, which is 1, not this one. So this is, listen, I'm going to name this, you name this other one. 1 is met. 1 is what? Met. Met, oxy. Met, oxy, and this is what? Ethane. 2 carbon atoms. Ethane. You know why I started with met and oxy? Now, what's the name of this one? And oxy what? Protein. Why did we say propoxyethane? Because the rule says that we start with the shortest what? Oxy group, which is this 1, 2. This is 1, 2, and this is 1, 2 what? 3. So this is an oxy what? Protein. Geometric stereoisomerism. I know you can name any compound, any term. We don't discuss metamerism. What we talk about is what? Nomenclature. Nobody reminded me. What we just think is nomenclature. Now, what is metamerism? Metamerism, look at, it's very easy. Listen up. Although the nomenclature is the most important thing I wanted you to get, look at this. Under metamerism, if I have something like this, what's the name of this one? What? Methoxy. Methoxy what? Ethane. Very good. Very, very good. Now, metamerism is very easy. Metamerism is just the movement of CH2 from the left to the right. If I move this CH2 from the left to the right, thereby changing the orientation of this structure, I will have something like this. CH3 to oxygen to CH2 to CH3. Look at this. Look at this. Movement, this thing. Movement of CH2 from the left to the where? Look at, I move this CH2 from the left to the right. Look at the CH2 here. This compound that is formed from this is called a metamer. What I wanted you to know is just nomenclature of ethers. you understand metamerism, let's look at the focal point. Geometric stereoisomerism. Please, if you have any questions, ask. Yes. Yes, the name will be the same. But some textbooks, see, do you know that if just I'm following your screen here, some textbooks will tell you that this is called epoxy. They will tell you that this is called epoxy, and this one is called the methoxy. Whether you say methoxy is just, I'm just going with, if it was maybe a different class, maybe like a jam class, that the curriculum is universal, I would name this as epoxy and this as methoxy. But your scheme here in our school, you will name using the shortest oxy group, which is this one, oxy, and this. Your scheme, you're not interested in the new compound that is formed. Your scheme, you don't have metamerism. Your scheme is you knowing how to name what? Pizza. And I believe everybody present here knows how to name any pizza. Yes. Yes, ask. Alright, yes, somebody was asking a question. Who was asking? No, you just move on to stage 2. When you move on to stage 2, what is happening? Alright, this is an epoxy compound. This is an epoxy compound. Who can try? What's the name of this? Who can try? Alright, please listen up. Whenever you have a cyclic structure, with an oxygen in between two carbon atoms, it is called a Furan ring. But listen, don't complain. I am learning with you. Let's proceed. Geometric stereoisomer. Geometric stereoisomer. Besides geometric, wait, listen up. Let's have a definition of geometric stereoisomer. Geometric stereoisomer is a type of isomerism in which the rotation between the two carbons is hindered by a double bond. Geometric stereoisomer or geometric stereoisomerism is a type of isomerism in which the rotation between the two carbon atoms is hindered by the presence of a double bond. A type of isomerism whereby free rotation is hindered by the presence of a double what? bond. We refer to that as what? Geometric stereoisomerism. Are we following? Yes. Did you get it? You got it right? Yes. Now please listen on. Please listen on. Please listen on. Geometric stereoisomerism is of two types. Number one is the cis geometric isomers. And number two is the trans geometric isomers. Another name for cis is called Zusammen. Zusammen is represented with a symbol Z. So Z isomers. And another name for trans means antigen. All right, let's continue. Listen up. Besides geometric isomerism follows a rule known as the can equal pre-log rule. Please listen up. This rule will help you know if it is a cis or trans isomer. What do I mean? If I have a structure like this, I said geometric isomerism follows can in both pre-log rules. I'm going to take this off. Now look at this. Please listen up. This structure 1, structure 2. I don't know why some persons are making a noise. Please stop making a noise now. If you don't want to get it, you want to make noise, you can go home. Alright, look at these two structures. Look at this. If I'm asked to name this structure, please listen up. If you're asked to name a cis-trans structure under geometric isomerism, we use a rule known as the can involve rule. Now, what does this rule say? The rule says that for you to name a structure as cis or trans, we give cognizance, that you must give cognizance, you must give significance to the substituent that is of a higher priority. How do we know the substituent that is of a higher priority? A substituent of a higher priority is that substituent with the highest atomic number. The substituent with the highest atomic what? Number. Carl is saying that for you to name a structure as cis or what? Trans, that substituent, for you to name a structure as cis or trans, that you must follow the rule of higher priority. And for you to know a structure that is of higher priority, it must have the highest atomic what? Number. Let us explain what I mean. Please listen up. If you look at structure 1, okay, before I name it now, let me ask you, structure 1, from what you know or what you think, is it cis or trans? Cis, raise your hands. Don't be scared to fail. Cis, raise your hands. Okay. Then trans, it means that everybody is trans. Some people don't want to raise their hands. Okay. All right, what about this one? What about this one? Cis or trans? You see, some persons are confused. That is where, listen up. Before you name the structure, wait, I've heard it. Calm down. Let us know using counting code. It's very easy. Counting code is telling us that for you to this your phones on silent. Please put your phones on silent. I'm battling with the noise you're making. I'm battling with aircraft noise. Please help me. Alright? This is hydrogen. This is CH3. Priority of this is higher than this. Hope you know why. Yes. This one has a higher priority compared to this. Hope you know why. Yes. So it means that